Hello viewers, Uganda taking you through the story of A-level pure mathematics. And in this video, we are going to go through the marking guide for Senior 5, Math Paper 1, End of Term 2 for the year 2024. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So this is what we hope to upload in this solid D. What is ticked means is already available on this platform, and what is not yet ticked means will be uploaded with time. And there are also books which I recommend you to buy. So for Principal Mathematics, there are 4 books. One is Math 1 Notes, Math 2 Notes, Term Papers with marking guides. So this one is what contains, so like for example, this video we are doing is a marking guide for end of term 2, so in the next year it will also be included, compiled in the book. So what we do, we compile termly exams, beginning of term, end of term, mocks, papers into a book. So that is what this book is all about. So it is updated every year. Then a topical question bank. Then for subsidiary math, it is only one book which contains notes, termly papers, and also past papers. For physics, there are 4 books also: Physics Part 1 Notes, Physics Part 2 Notes, Topical Question Bank, and its solutions. For any of the copies, contact the author on this contact. So now we shall go to section. This file also was split into 2 sections. Section A and Section B. Section A has 40 marks. So, and you are supposed to answer all. They are compulsory. So question 1 says, if this is equal to 9, okay, find the value of first derivative, second derivative at the point -2, -3. That means that x is -2, y is -3. So this is an implicit function. This is an implicit function. So I need to differentiate both sides. Therefore, differentiate this, you get that. Differentiate this, you come up with that. And differentiate this, you come up with that. Differentiate this, you come up with that. I think by now you know how to differentiate implicit functions. Then simplify and collect like terms. So I've taken the dy dx this side to give you this. Then from there you shall remember that at this point x is -2, y is -3, so I can get the value of dy dx, which will be -3. Now that was first derivative. For second derivative, we again differentiate both sides. Differentiate this and also differentiate this. So when we do that, we shall come up with this expression here for the left hand side, for the right hand side. And then we simplify. So at this, you can come and substitute. This is that. Remember, dy dx, we already got it. It was -3. Then x is that, y is that. This is what we want. Dy dx was -3, 1, then -3 gives you +3. So simplify and make the second derivative the subject. And that's what they wanted. Then question 2 says, find the value of a for which this has repeated roots. So 1, we have to expand and rearrange. Open brackets and rearrange x squared alone, x alone, and constants alone. Then condition for repeated roots, b squared, which is this, minus 4ac is equal to 0. So expand, open brackets, and then you simplify to get a quadratic, which can be solved by the quadratic formula to get the 2 values of a. And that's what they wanted. Then question 3, ABCD is a rhombus. Okay, A is the point this and C is the point this. Find the equation of the diagonal BD and the area of the rhombus if the length of BD is 4√2 units. So there we need to make a sketch of the rhombus. Then you show the diagonals SC and BD. The diagonals make an angle of 90. Now they told us the length is of BD is 4√2, meaning that divides into 2. That's why you see here 2√2, 2√2. So gradient of SC for this line, gradient is change in y over change in x to give you positive 4. Therefore, gradient of BD, because they're perpendicular, will be negative reciprocal of this gradient. What about midpoint? Midpoint of SC is M, and it's got by getting the average of the x coordinates and y coordinates to give you that. So why did we bother to get that midpoint? Because once you know the gradient of this BD and we know a point on that line, we can get the equation of that line. So now shall come and say that the equation of line BD will be given by equating the gradients, where xy is a variable point on the line. So cross multiply and correct like terms to get the equation of the gradient. Then length SC is given by this formula, change in x squared, change in y squared, to give you that units. Why do we want that? Because we want to use it to get the area of the rhombus. So area of the rhombus is twice the area of a triangle ABC. So area of triangle ABC, let's first go here. Area of triangle ABC. We have this as base and this as height. So half base height times 2 to get the area of the rhombus, which is required. Then question 4 says, find the equation of the line L that passes through the point this and perpendicular to the line this, and hence find the shortest distance between the line L and the equation that. So for this line, gradient is this, but I told us they are perpendicular. Line L is perpendicular to this line. So that means that the gradient is the negative reciprocal of this gradient, which gives you 4/3 positive as the gradient of L. Now I know the gradient of L and I know a point through L. So I can get the equation of line L by equating gradients where xy is a variable point. Cross multiply and rearrange to get the required equation. So shortest distance between line L and this equation. So the good thing, I know a point on line L. So that's what I'm going to use. As if they have told you to get the shortest distance of this point from this line. So I'll come and substitute here 3x, sorry, no, that one. Here there is 3y, y is this, then minus, because everything has to be put on one side, minus 4x, where x is this, then this one also goes this side to become plus 12, which is here. Then over the square root of the squares of the coefficients, this squared and this squared. So that formula for this formula is also available in the logbook. So when you simplify, you come up with 1 unit as the shortest distance, and that's what they wanted. Then question 5 says, given that the roots of the equation this are alpha and beta, determine the equation with integral coefficients whose roots are this. So from here, sum of roots is negative of negative 4 over 2 to give you positive 2. Then product is negative 3 over 2 to give you that. Then for the new equation, product of roots is got by multiplying this. Get LCM. Then you expand this, but don't tamper with this square first. So come up with that. So this is sum of roots, and this is the product. So simplify to get 4 over 9. That was product. What about sum? So sum also get the LCM, expand the numerator, but the numerator is already known from the product. Rearrange, so this with this can be combined into 2 to get the sum, which is here. Then this one can be expressed in terms of sum and product, and substitute for sum and substitute for sum here and product here. You come up with 52 over 9. Therefore, the required equation is given by x squared minus sum times x plus product. So substitute the sum and the product, and that's what they wanted. So you can either choose to multiply throughout. That's about simplifying. Then question 6 says, prove that cos theta is equal to this. So let t be equal to tan theta. So cos 4 theta is equal to this minus this. I think we know that. Then cos squared this gives you this, and sin squared this gives you that. In terms of t formula. Then here I'll get the LCM, combine into one LCM. And then we rearrange just. So when you rearrange, we shall come up with what they want. So this is here, this with this is here, this is here. Then this is here, this is here, this is here. So t is the same as tan theta, so come and substitute where there is t, you put there tan theta, which is the required expression. Then question 7 says, solve the equation this for values of theta ranging from that to that. So first we write the given equation. So here what I've done, remember, do you see theta, 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 but this is 2 theta. So I have to change it using the double angle identity to come up with this. Then from there I realize that sin theta is common here. So pull it out to come up with that. So here we don't cancel. Then from there I realize something. Do you see this and this? They are the same. They are the same, but we don't cancel, we factorize. That's why I brought the whole of this side to come up with this expression. And I can factorize. This is here. Here I remain with 1. Here I remain with sin theta to give you this. Either this is equal to 0 or this is equal to 0. For this equal to 0, sin theta is 1. For this, sin theta is that. Meaning that tan theta is equal to 2. Then I can get the values of theta. For this I have that, for this I have that, based on this range. Okay, so that is what they wanted. Then question 8 says differentiate this and simplify as simply as possible. So for now, you have not yet learned natural logarithms, so we are going to just use the quotient rule or quotient formula. So here it means that this power is on both the numerator and denominator. That's why we did that. Then from there, quotient says keep this constant, which is v, then differentiate this one, which is du dx, to give you this. So when I differentiate, bring down the power, reduce the power by 1, differentiate the inner bracket. Then minus, keep this constant, which is here, and differentiate this to give you the whole of this. After that, divide by the square of this denominator to give you this. The next is to factorize. You realize that this is common, okay? And is there any other? This is common. So we pull out the one with the smallest power. Even 2 is common. So 2 goes out. This with this one has the smallest power. That's why what we pull out. This with this, it is this with the smallest power, so we pull it out. Then we simplify for this first term. 1 goes with this. That's why we remain with only 1 this. Then this goes with this. Okay. Then this goes with this. So I'm going to remain with this one or with this one. So I add it also here. I've just simply chosen to factorize out the 2 because it's common. That's why I say 2 here. Then this with this, 2 goes away. This goes away. This reduces this, so I remain with one of them. And this negative deals with this negative to give you a positive. Now I'm going to open this bracket to give you this. Remember, they want you to simplify as simply as possible. So now I'm going to open the whole of this inner curve brackets. So you come up with this. After that, I will collect like terms. You realize that this goes with this. Okay. Then this and this remain with the negative that. 8x now it is here. 8 is here. So that is what they wanted. Then section B now. Question 9 says, part A, use the substitution this to solve the equation this. So what you should realize is that this is symmetrical. Do you see this 2, 2, 9, 9, and the middle term? So it is a symmetrical formula, quadratic formula. So how do we deal with that? We first begin by squaring this. So square this to give you this, simplify to give you this. Then you realize that you have something. Do you see? So I want to make this the subject. I'll come up with this being equal to this. There is a reason why we have done that. We are going to see it as we go, as we proceed. But that should always be the first step. But this works for symmetric equations. And symmetric, I've told you, this, do you see that? Do you see that? And the middle term. Okay. So I'm going to just rearrange, put these together, 2 with a 2, this negative with the negative 9, then the middle term now is isolated. Then why do we do that? We want to get something similar to this. Something similar to this, and we're going to get it. So what I've done, I've divided throughout by x squared. This by x squared you get this, 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 by x squared you get this. Then I can factorize out 2 here to remain with this, okay? Negative 9 here to remain with this, and this remains alone. So I think you have seen that you have got something similar, isn't it? So this one you replace, this replace. Now you have simplified a quadratic equation which can be solved using quadratic formula to get the 2 values of y. But remember, we are the ones who introduced in the y. They want the values of x. So we need to come here and get the value of x for each value of y. So multiply throughout by x to get the quadratic equation, which can give you the value of x. Then you also substitute, multiply throughout by x, by 2x to get that. So solve the quadratic equation to get the 2 values of x. And that's what they wanted. So that is how they solve symmetric equations. Then part B says solve the inequality, this one. So there are magnitudes. Magnitude means plus or minus. So to remove the plus or minus, you have to square both sides. Then we expand, open brackets, collect like terms. So this goes this side to give you this. This goes this side to give you this. And this goes this side to give you this. Then leaving this side within less or equal to 0. So simplify, you get that. Then now we have to factorize. So the 2 factors whose sum is negative 20 and product is this, which is negative, let's see, 12 times 25, which is 300, negative 300, are these ones. So when you add, you get negative 20. When you multiply, you get negative 300. So I can now factorize by grouping. So group and factorize, then factorize completely to get the critical values. Then we need the table of signs. So for values before this, we can use -1. So this is negative, negative to give you positive. For values between this and this, we can use 0. This will now become negative, positive to give you negative. Then for values beyond this, we can use 3. So 3 gives you positive here, positive. But remember, less or equal to 0 means negative values, so we're interested in this. Therefore, the solution set will be this. Now, why is it a little different? Do you see something? Here it's just less than, here it's less. Okay, here it's x greater than, here it's just x greater than or equal to. X less than, here it's x less or equal to. Why? Because of this. So if this one has or equal to, we also put or equal to here. Then question 10 part A says, find the equation of the circle that passes through the points this, this, and that. Let's begin with that. So one, the general equation of the circle is given by this. Then we can now use different points. Using this point, I can come up with that, equation 1. Then using the point B, substitute for x and y to get equation 2. Using point C, substitute for x and y to get equation 3. Those are 3 equations, 3 unknowns, so we need to solve them simultaneously. So subtracting equation 2 minus equation 1, we shall come up with this as equation 4, where C has been eliminated. Do the same, equation 2 minus equation 3, we shall come up with equation 5, where C has been eliminated. So we need to reduce. So now these are 2 equations with 2 unknowns, so they can also be solved simultaneously. Okay, so when solve them, we shall come up with this. In that case, it means we're going to eliminate f to remain with g, and g will be equal to -5. Then I can either use equation 4 or 5. So when I use equation 5, I come up with the value of f as that. Then I can either use equation 1 or 2 or 3. So when I use equation 1, I can come up with the value of c as that. Therefore, the general equation, the equation of the circle is now, you substitute for f, g, and c. And that's what they wanted. Then part B says the point O, which is 0, 0, and Q, which is 4, 0, are fixed points. Okay. P, X, Y is a variable point such that the angle OPQ is 45 degrees. Show that the locus of P, which is XY, is this. So gradient of P, because we have O, P, Q. So gradient of OP is that, and gradient of PQ is that. Since gradient this is greater than gradient that, according to this, do you see something? This is just x, the numerators are the same. But denominators, this is x, and this is x minus 4. So this should be, the denominator here is smaller, meaning that the whole of this expression is big. For example, if I have 4 over 1 and 4 over 3, which is smaller? The whole of this is smaller, but it has a bigger denominator. And this one is bigger because it has a smaller denominator. So of these two, this one has a smaller denominator, so it will be bigger. Therefore, using the formula, you can come up with that. So if you are not sure what you do, you put magnitudes. If you are not sure what you do, you put magnitudes. But now, since I'm already sure, I can leave them. Then I substitute, get LCM for the upper part, LCM for the lower part. Then you realize the LCMs are the same, so they can cancel to remain with that. So these ones can cancel, and I remain with that. Expand, rearrange. So you realize that this and this cancels. To rearrange to get the required locus. So now shall go to question 11. Part A says solve for x in this. So if you first rewrite the given equation, then prime factorize the 25, then bring the 2 this side, then we can now change the base to base 5, and we let y to be equal to that. So substitute for y, substitute for this to give you this, and this to give you this. Then multiply throughout by y. So now we are going to get a quadratic equation which can be solved using a quadratic formula to get the values of y. But we are the ones who are introducing the y, so we bring back the logarithm and we eliminate the logarithm to get the two values of x. And that's what they wanted. So part B says, part B, show that when the quadratic equation this and this have a common root, then this is equal to this. Okay. So let the common root be alpha. So shall I substitute where there is x, we put the alpha to get the two equations. Now I want to solve them simultaneously to get the value of beta. Sorry, we're substituting beta. So what I will do you see something? Here, I want to emit a beta squared. But here there is 8 beta squared. Here there is 5 beta squared. So I multiply this by 5 and multiply this by a through. That's why you see here a in equation 2 and 5 in equation 1. So when I multiply and subtract, I'll come up with that. So this goes away. Then this gives you this. And this gives you this. Make beta the subject. You'll come up with that as equation 3. So now what I'm going to do, I'm going to substitute for this beta. Either it is you to choose. Either I substitute in equation 1 or in equation 2. Whatever I choose is okay. So substituting equation 3 into equation 1, I get that. Then expand, cross multiply. So this one is a squared. So multiply by this, it means one of them goes away. You remain with this. And with this, the whole of the square remains. Then here what I've done, I've taken these two terms this side. This one goes this side to become positive, this goes this side to become negative. Then from there I realize that something is common. This and this. I'll pull it out. So here this will go away, I'll remain with this. Here the power will go, I'll remain with this, and this power 1. Okay. Then you now deal with this box bracket, expand it, you come up with this. Now here I realize that this and this can cancel, so we're going to remain with this. Okay, so I'm somehow getting the proof, but let me first see the proof, how it is. Let me first see how the proof is. Proof, now the proof here, there's no a, you see here, there is no a. Also here it is BP minus CP, and it is here it is AP minus 5B. Okay, let us see what we have. For us here we have 5B minus AP, OPA. For them they have AP minus 5B, so something needs to be done. Then also them, they don't have here A. So what I'm going to do, I'm going to factorize out negative A. Negative A. So negative A here I'm going to remain with now BQ minus CP. Okay, now this A will go with this, and this negative will come inside. So I think you see that now we are getting what they wanted. So basically that's what they wanted. Then question 12 part A says, given that t is equal to this, prove that this is equal to cot theta over 2 for this range, and hence solve the equation this for this range. Okay. So we are going to begin from the left hand side and use t formula, this, substitute with t formula for sine and for cos. Then get LCM for the numerator, LCM for the denominator. So this and this are the same, so they can cancel. And also you realize that this and this can cancel, so you remain with the 2 alone. Up, down you remain with the 2t. So 2 can cancel to remain with 1 over t, which is 1 over tan theta over 2 to give you cot theta over 2. Then for the hence part, they give you that equation. I have to rearrange and get something like this. So what I'm going to do, I'm going to take this one this side to give you this. factorize out root 3 and then divide. So I've got something like this. So I'm going to replace it with this here. So replace, giving you tan theta over 2 as root 3. Therefore, theta over 2 is 60 and theta is 120. And that's what they wanted. Okay. Then part B says, given that sine theta plus cos alpha is x and sine alpha minus cos theta is y, show that cosec this is equal to this. So here it is better you begin from this right hand side. Now I want you to realize is that here they said theta minus alpha, meaning theta is bigger than alpha. There's a reason why. We shall see why it is important. So let me first deal with the denominator alone. This is the denominator, substitute for x, substitute for y, then expand. This squared gives you this, and this squared gives you this. Then from there, you can collect like terms. You see this, this, and this can be paired to give you this. Okay, this and this can be paired to give you this. Then there is this one, and this one, and this one. Why did I rearrange? It is because there's an identity which can make this equal to 1 and this equal to 1. Then you remain with this, this, and this. Okay, now this with this cancels, you remain with this and this. So then you can use factor formula. This alone gives this, sine plus sine. Why? Because we saw that this is bigger. Then this gives you sine minus sine. Then you can rearrange. You realize that this and this cancels. This and this gives you addition. So you get 2 sine in brackets alpha theta minus alpha. That was the denominator alone. So I'll go back in my right hand side actually. So this should be right hand side. Substitute for this denominator to get the cosec which they wanted. Then question 13 says, part A, given that x is this and y is this, find the second derivative in simplest form. So these are parameters now, parametric differentiation. So dx dt gives you this, simplify to get that, and dy dt gives you this, simplify to get that. Then you use chain rule to get dy dx. So this is dy dt, dt dx to give you this. So now that I've got dy dx, I can now get the second derivative, but still using chain rule. Because there is still t. So there's a quotient. Can differentiate to get that. Times dt dx. Simplify. So when I simplify, I come up with that. The next is to factorize. So this is common, this is common, and this is common. So we factorize them out. Then from there, we shall realize that for this one, this goes with this goes with this, and this reduces this power by 1 to remain with t minus 2. For this one, this goes with this goes with this, and this reduces this power by 1 to remain with t plus 3. then times this dt dx, which is here. Then from there, I open this bracket to come up with this. And from there, realize that t cancels. So I'm going to remain with negative 5 here. Then negative 2 times negative 5 is positive 10 times this, which is here, over 9 this, which is there. So I can pull out these constants, and this one's the same power. I put them together. That is the simplified form they wanted. Then part B, says, find the coordinates of point on the curve x this and this, y equal to that, at which dy dx is 0. So they want you to first get dy dx and equate to 0. So x is that, y is that, so dx dt gives that, dy dt gives that. Therefore, dy dx by chain rule, I'll come up with this product, which can be simplified to get that. But dy dx is 0, so come and equate this to 0. The whole of this goes away, remember this equal to 0. Therefore, t is 3. But they wanted the coordinates, so I need to get the value of x and y. So here where there is t, put there 3. Here where there is t, put there 3. To get the two values, then you can write in coordinate form. And that's what they wanted. Then question 14 says, part H says, show that the line this is a tangent to the curve this if this is equal to that. So that's also still condition for tangency. So substitute for y, expand, and rearrange. Then from there you can remember the condition for tangency, that they are repeated roots. So substitute in the condition, expand. So I've expanded this one to give you this. Then this 4 can cancel to give you that. Then remove the bracket to give you this. Then from there I realize that this and this can cancel to give you that. Then take this on this side to give you the required expression. Then part B. Part B, they said, find the equation of tangent to the curve this at the point this. If the tangent meets the x-axis at A and y-axis at B, find the equation of the locus of M, the midpoint of AB. So one, we have to get the gradient. So at this point, the gradient of the tangent is given by that. Therefore, I can get the equation of the tangent. Equal gradients, cross multiply, rearrange. Then at the y-axis, y is equal to 0. So when y is equal to 0, x is that. Therefore, point is given by those coordinates. Then when x is 0, you come up with that. Therefore, point B is that. Then midpoint is got by the average, which is that. So they want the locus through of this midpoint. So it means that you are going to eliminate t. So locus here, x. Okay, let's begin with y. Y is 2t, therefore t is that. And from here, x is this, therefore substitute for t. So locus is about eliminating the third parameter. So substitute for t, what you get will be the locus. And that's what they wanted.